going to talk about vertical stretches and compressions. A stretch, that's going to be when your graph gets narrow. So you can write narrow next to stretch. And then a compression, that's when your graph gets wider. Okay, so think when you stretch your arms in gym class, they get closer together, you're trying to be really tall. So the red parabola is going to be the narrowest, and the green parabola is the widest. So yesterday we talked about the parent function. The parent function is y equals x squared. The b value is 0 and the c value is 0. So take a look at your three graphs. The parent function, I need to figure out if that's green, blue, or red. So something I can do is make a table of values for the parent function. So x could be 0, 1, and 2. So I'm going to plug 0 into the parent function. So 0 squared is 0, 1 squared is 1, and 2 squared is 4. So the point 0, 0, 1, 1, and 2, 4, they happen to be on the green graph. So my green graph is y equals x squared. So circle y equals x squared in the same color that you're going to trace the graph that goes with it. Okay, now if I look at part B, it says, how do the other two graphs compare to the parent function? Well, the other graphs are skinnier. The other two graphs are skinnier or more narrow. Okay, so let's figure out which graph the blue one goes with. Okay, so my options are 2x squared or 4x squared. So I can go on my calculator and I could type in 2x squared and graph it. Find the points that go with 0, 1, and 2 in my table. So 0, 0, 1, 2, and 2, 8. So when x was 0, y was 0. When x was 1, y was 2. And when x was 2, y was 8. So if I look at the blue graph, 0, 0, 1, 2, and 2, 8, all fall on the blue graph, so the blue graph must be 2x squared. Okay, by process of elimination, the red graph is 4x squared. So if I want to go on my graphing calculator, I can graph 2x squared and 4x squared together to compare that the 4x squared is more narrow. So now let's summarize what we've learned. The a values are 1, 2, and 4. So when the a value gets bigger, the graph gets skinnier. So when the a value gets larger, the parabola gets more narrow. Okay, so in general, if a is greater than 1, we call that a vertical stretch. The parabola has a vertical stretch. Remember, stretch means narrow. Okay, now for part 2, I have A values that are fractions. So once again, we'll trace each graph in a different color and circle the matching graph. So your parent function is still in green. So the parent function is y equals x squared. So I remember the point 1, 1, 2, 4. Those are all on the parent function. So now I want to compare the blue and the red graph. So I'm just going to graph half x squared and a fourth x squared in my calculator at the same time. Okay, so 1/2 x squared, and then a fourth x squared, that's a smaller fraction. So they'll graph in the same order. So the blue one is 1/2 x squared, and the red one is a fourth x squared. So the fourth x squared is wider. So I know the blue one goes with 1/2 x squared. That's the one in the middle. And my red parabola goes with 1/4 x squared. That's the one that's the widest. Okay, so we're going to summarize. Part B says, how do the other two graphs compare to the graph of the parent function? The other two graphs are now wider. In part C, how do the other two graphs compare to the parent function? Sorry, the other two functions. So now I'm looking at x squared, 1/2 x squared, and a fourth x squared. So the smaller a value makes the graph wider. So a fraction like 1/20 x squared, if I wanted to graph that, that's going to be the widest one. So the smaller the number, and it has to be a fraction, the wider the parabola will get. So in general, if the a value is a fraction, it's called a compression. So if the a value is a fraction, I can say it's greater than 0, but less than 1. That's how you would write that. In other words, a fraction. The transformation is called a vertical compression.